Yes, ma'am.
Is the document visible to you people?
Yes, ma'am.
Okay, fine.
Ma'am, I think
Yes.
the picture where the diagrams are illustrated circuit diagram, it's not clear.
Yes,
It may
yes,
be
yes.
due to
That's
the dark mode. For
yeah. I'll just thank you.
Deepasri, this is Mahesh from studio team. Hello.
Yes. Yes.
Can you make it landscape that whatever you are sharing, the PPT something, okay? Make it as your
Okay.
landscape. Don't
Mm,
make it in portrait, okay?
check.
Hello. Hello.
Give me some time, please. My voice is audible to everyone now?
Yes.
Yeah, right, then we'll continue. I'll just share my screen. The document is visible.
Yes, it is visible.
So for today's experiment, if anyone has any doubts, please let me know.
Should I say it now or later? Hello.
Shall I give you a like brief of the experiment? Then
Am I audible?
Yes,
Hello.
ma'am, please.
yes, yes, you're audible. Yeah.
Should I do my doubts now or later? Ask my doubts.
Better, I'll give you an explanation of the experiment, brief of the experiment. Then you can tell me. Fine? Is it fine?
Yes.
Yes, ma'am, it will be fine.
So number of participants are 12. So as I can see, so we'll start then. It's 4:17. So we'll start now. This is an experiment to understand the characteristics of BJT and MOSFET transistors, and we are using them to as a to drive to light an LED as a driver circuit. So by using a driver circuit, so the materials that will be required here, I think all the materials has been delivered to you. BJT and channel MOSFET, LED, 1 kilo ohm potentiometer, 1 kilo ohm resistors. Just a minute. Pardon me, my laptop is not helping me today. So you can just bear with it. Sorry. So my voice is audible, right?
Yes,
Yes, ma'am, it's fine.
Okay, fine. Thank you. So we'll continue. So with the connecting wires and multimeter, everything. So we will go to the part 1. So it has 3 parts. Okay. So here, don't confuse with part 2 as it is some mistake. Okay. So it has 4 parts altogether. So you have to go through each and every parts carefully and show them individually in the experimental video that you will do, so that it will be easier for us to give marks to you. Then we'll start for the first part. This is transistor characterization experiment to characterize the behavior of both bipolar transistor and MOSFET transistors. So just the some parameters will change depending on the transistors that you use. So set up according to referred figure 1. So you'll have a 2.5 volt voltage in parallel with a potentiometer port that is already been provided to you, that you will connect through RB to the transistor for BJT, BJT or MOSFET, whatever, and there will be another voltage source that you will connect to the collector of the BJT collector part of the BJT through an RC resistor. So choose an appropriate fixed voltage value for VBE or VGS based on the transistor. So whatever the transistor has been provided to you. So just go through the data sheet of the transistor. So when you work with this kind of transistors, better the first thing you should do is you should go through the transistor data sheet and there will be some threshold value for VBE. Okay, so maintain that value, and then both for BJT and MOSFET, and accordingly measure, and at that fixed value, third point is measure and record the base current. So you using this port where you are this is base, this is emitter. Okay. Now using this is 2.5 volt DC voltage. So using RP, that is a potentiometer, you will regulate it and make it such that the VBE comes at the threshold value that has been specified in the transistor datasheet. Okay, we'll whatever the doubts you will have, you can ask me later. We'll just go through the experiment. If in between my voice is not audible to you, then you just notify me. Then measure and record at that voltage, measure and record the base current for the fixed VBE or VGS. So using a multimeter and or a current multimeter you can use here. So we whatever the you can how you will measure, you take the voltage across RB. Okay, so whatever the voltage across RB will be divided by the RB value, you will give the IB. Now vary the collector emitter voltage by once this has been fixed, now what we'll do is vary the collector emitter voltage by varying this VCC. By varying VCC from 0 to 5 volt in steps of maybe 0.5 in steps of 0.5 volt individually. Now for each voltage step, measure and record the IC and using a multimeter. Same thing you will do for the MOSFET. Plot here for the BJT transistor, you will see IC versus VC value, that is the output characteristics. Now for MOS, you will see ID versus VDS value, that is the aim. So you will just replace BJT with the MOSFET and check. So it has both the things, like in this figure, don't do only BJT. Some people will do only BJT and not show the MOS characteristics. So that will deduct some marks for them. So attempt both the transistors and then show the output characteristics, IC versus IC versus VCE, and for MOS ID versus VDS. Now, next is the BJT driver circuit. Okay, to study the behavior of a BJT driver circuit for driving an LED and analyze its performance under varying input conditions. Now, what we are doing here is we refer to figure 2. Connect the components as shown in the schematic diagram. Resistors RC will be 200 ohm, RB will be 5 kilo ohm. So that is being specified. So apply 5 volt DC across the potentiometer. The VS will be 5 volt across the potentiometer, and adjust its variable voltage terminal to the lowest voltage output. Now you will put the RP potentiometer such that it gives the lowest voltage. Okay. So VS is a constant 5 volt. Now how we will vary the IB, or how much current is getting into the BJT. Now that you will do through using the potentiometer. So you will check that depending on IB, the IC will change. So what that will show that the intensity of light at the LED will change. So that is our main aim, to see how if we change IB, how the LED behaves. So this is a LED driver circuit, right? So that is our aim. So gradually increase the voltage. You will put the potentiometer in the lowest available voltage, then the lowest available resistance, and then you will increase. Then gradually you increase, adjust, means across the potentiometer, apply and adjust the variable voltage terminal to the lowest voltage input. So you will ensure that it provides the lowest input voltage. Gradually increase the voltage output of the potentiometer and observe the brightness of level of the LED, as I have already explained before. Now measure and record the voltages across the collector emitter of the BJT for both off and on conditions of it. So when the LED is off, measure the IC IB value, the voltage across RC. So IC how will measure measure the voltage across the RC and divided by the RC value will give you the IC. So note the voltages across the LED also. So note the voltage across LED also when the LED is off and the LED is on at both the points of time. Now note the base current for both the cases. So what you have to do is basically measure all the parameters that will be changing with the changing voltage across here. So you have to measure IB, you have to measure RC, you have to measure IB, and you have to measure IC. You have to measure how much the voltage across LED is changing. All those cases both for off and on conditions. Now what you'll do is remove RB here when the BJT is on. and note the voltage at the variable terminal of the potentiometer. So that you have to find it out, and what is the importance of it. You have to read the theory, and why, if you remove RB, what is the actual voltage and what is happening. But if you don't remove RB, what is the voltage, and when you remove RB, what is the voltage, actual voltage, you will have an idea, and you have to specify a reason for that in your video. Now the same experiment you will repeat for using the MOS transistor driver circuit. It is a part 3. So step and procedure is replace the BJT with a MOS transistor, adjust resistor values if necessary to accommodate the MOS transistor requirements. Example, RB is not required because MOS is a voltage driven circuit, that transistor. So but you specify that why RB is not required. So if you don't put the RB, it will not affect why. So you have to give the reasoning in your video. Based on the experience with the BJT and MOS transistor driver circuits, draw conclusions regarding their suitability, efficiency, and practical considerations for driving LEDs and similar applications. So you have to specify that which one is better, which one better in which cases. So, and also what are the advantages and disadvantages, particularly for different transistors with BJT. What is the plus point of BJT? What is the negative point for BJT? So those things, and also for MOSFET. So all those things you have to specify and give a explanation in your video. The last part is light dependent resistor LDR controlled LED. So LDR, it's, I think, when it is exposed to light, the resistance decreases. Please correct me. Yeah, if I'm wrong, I got. So in LDR, to design and implement a circuit, what we have done is very simple. When the LDR will be exposed to light, the resistance will change, and accordingly, the IB will change also. And if the IB changes, the IC will change, and the intensity of light will also change. So what you will do is, once you will block the LDR and see that whether the LED is glowing or not. And once you remove it, you expose the LDR to light and see what is happening to LED here, whether it is glowing or not. So that is a simple experiment. Refer to the 3 for that. Connect the components as shown together. So adjust RP so that the functionality mentioned in the objective is achieved. RP may be replaced with a fixed resistor, because here LDR is varying, no? So we can also just connect a fixed resistor also, so that will not change the circuit as such. So we are note the voltage across the LDR, because we are not doing anything with the RP value. So we can also replace it with the fixed resistor. Note the voltage across the LDR and the current through the LED when the LDR is exposed to light and kept in darkness. So what you have to do is, when you are exposed to light or darkness, at both the times you have to measure the voltage across LDR and LED respectively. So that will give you an idea that whether what is the voltage, at what voltage the LED glows, at what voltage the LED goes off. So those things you will get an idea, and why you have to also specify the reason for it. So that is all from this experiment. So if you have any doubts, please share with me.
Hello.
Yeah.
I have a question that for the first part, where I have
Yes.
to find the IB characteristics of MOS and BJT, can I use a different setup, different circuit?
No. This circuit is given just because, so that you can like have a, because if you change the setup itself, then it is difficult to, like, for us to check. So this circuit
So
is
if I explain my circuit and everything what I have done in the video, and how I got the IB characteristics of MOS and BJT, will it be okay?
No, why is my question is what is the need for it? This circuit is properly working. Everybody is doing this circuit. Why
It
do you
is
have to?
working, but I got documentation from ADLM, like their documentation where they have done how to find out the IP characteristics.
So that
So
is that you can do for your own like own experiment, but you have to show this experiment in the video, not
Okay.
any other.
And
Yeah.
for the first part, how will we get the RC and RB value?
Huh?
For the first part, how will we get the RC and RP value?
It is already specified, right? RC value. Sorry, here it is not specified, right? I'll just tell. The next experiment is specified. Sorry, it has been not given here. Okay. So RV will put it 200 ohm. Sorry, RC 200 ohm and RB 5 kilo.
Same,
Here it
same
is not
value for both
specified,
the
right?
resistance. Hello? We
Yes.
will use the same value for
Same volume.
part
Yeah,
1
yeah.
and 2.
Yeah. I think by mistake we have not provided this values. So refer the same values. Okay.
I have already
Ma'am,
set up the circuit with 1 kilo ohm resistor for base and 200 ohm resistor for the collector part. So is it an issue, ma'am? In the first part where we characterize the transistor.
Yeah, see, if RV increases, so some IB also will change, right? So, but if you get the correct characteristics, correct, that is fine. Yeah, if you have already set
Okay.
up, if you get the correct characteristics, IC versus IVC, then I think I can consider. Okay.
But originally you are telling that it should be
Yeah,
5 kilo ohm and
not
across
should be.
the base. And
It should not be. We just gave you just random like okay, RB should be 5 kilo ohm. What you have done is 1 kilo ohm RB, right?
yes, ma'am.
Okay, okay. So more current. So yeah, fine. As long as you get the correct characteristics, so that is fine for us. RV doesn't play a
Okay.
big role
Even
here.
I thought that it would be easy if I use 1 kilo ohm because the current value will be straightforward in milliohms. I don't have to divide by anything.
Okay,
That's
fine. But as long as you get the same correct characteristics, the whole experiment is working because RB doesn't play a very big role, so that is fine. In case of MOSFET, it doesn't affect, right? So it's fine as long as you get outputs right.
And ma'am,
Uh,
as told that we have to look into the data set for what voltage to be provided as the base voltage. Suppose it's zero point 0.7 volts for it, but what should be then? It should be exactly zero point 0.7 volts, or we can give zero point 0.8 volt or 0.85.
Correct. Yeah, you can just start from 0.8. If it is 0.7, you can also keep 0.7, or you can keep it from 0.8 like that also. Because other below that it will not work, no, this
Yes,
threshold.
ma'am.
So that is the reason.
So we have to experiment a little bit and choose a fixed value. Say
Exactly.
that works. Yeah. And
Yeah.
for that fixed value, we have to just vary the collector emitter voltage.
No. What will once? Yes. Correct.
Yes, ma'am.
Yes. Any more doubts?
Is there any use with the 1 kilo ohm resistor?
What?
No, in materials and equipment, it is asked to have some 1 kilo ohm resistor.
This is a pot. Okay, potentiometer.
No, they are also asking for the resistors.
Oh, okay. No. Just we have put it like that. 1 kilo ohm resistors. That is not like whatever values are specified here. RC, RV value. Put it like that. If you have 5 kilo ohm, use that 5 kilo ohm resistor itself.
Sure, ma'am. Ma'am, and making these experiments coming like shrinking it, the 3 to 5 minutes of video is not possible for many of us.
What? I did not get.
No,
See?
I'm actually for in instructions in week 5, it is asked to have the video duration from 3 to 5 minutes, and not more than that. And it is not. It cannot be possible to have such a detailed video within 3 to 5 minutes.
We don't want that much of a detailed video. Like, okay, I have taken 5 kilo ohm resistor. You can crop it, okay, while taking the video and make a club those videos together, okay. Because maximum people, what they do is, okay, we have taken 5 kilo ohm resistor, we have taken 200 ohm resistor, and we have put it like that. No, you just do the for in the beginning, you can say that, okay, this is a 200 kilo ohm resistor, the other 5 kilo ohm resistor we have already measured. Now you will do what, you will just put make the circuit, okay, make the circuit, and then say this is the circuit, and just show the node voltages, okay. So for example, I'm talking about this experiment, okay, figure 1. So you have make the experiment, make the circuit, okay. Now what you will show is that you at node this, what is the voltage, okay, this is the voltage coming here. Now I'm varying the voltage, varying the VCC. Like, first of all, what you'll do is that make the fixed voltage, you will do keep and show the voltage across this one, voltage across RB, like this, okay. This is the voltage it is coming in multimeter. Now this part is done. Now we will show some values, like let's say at 0 volt of VCC, what is the voltage across IC, what is IC, what is the IC value coming, you can show. Means IC or VC value, VC divided by RC, this is the value it is coming, correct. Now maybe you will take some random value, 2 volt, it is coming like this. Again, some voltages across RC will measure with an multimeter, it is showing some. Now at the end, what you can show is, okay, okay, I've taken this much of readings, and show, make a table in your notebook, okay, and take a picture of the introduce that picture in the video, and then say, okay, this is the picture, or you can just plot in Excel, show the screenshot that, okay, I have taken this many of readings, like using this circuit, and this is the plot I have got. That's it, okay.
Yeah, okay.
Not very elaborative, okay.
Sure.
So I think that will help you out.
Is it okay if we just show do the experiment in the video and just show the readings of it? Is it okay like that?
See, you have to show some real-time value, real-time output values, okay. That is
Yeah,
our aim, so
okay.
that we can.
If it is possible to compare with the notes taken over here with the practical values, it's okay.
This is that also, it will help. It is a good representation also, that theoretically it should come this much, in practically it is coming this much. So that will also, those theoretical calculation you do not need to show and everything, you just have to
no, I'm just showing that readings, showing the readings.
Readings, yeah. So but 1 or 2 values you have to show experimentally, okay, this is the value I am giving, this is at this much of VCC I am getting this much voltage across RC. So 2, 3, at least minimum 5 values you can show in the video, and then you can show the plot. That's it.
Sure. Okay.
Yeah. Any more doubt?
Ma'am, right now I have covered till week 7 of the theory course, and I am familiar with the BJT transistor. But ma'am, I'm not familiar with the MOS transistor. I think I have checked. There is nothing mentioned for the MOS transistor. Ma'am, so where can I get the reference of it?
There are so many YouTube videos also, no? You can just have a look.
Ma'am, actually, the week 10 videos of electrical and electronics is about a MOSFET.
But currently only week 9 have been released, and week 9 is the problem solving week. Yeah. So we don't know how a MOS behaves. That's why I was asking.
It is not explained in the class, like that classes that you are taking.
Ma'am, till now we don't know about MOS characteristic. I have covered till week 7 and also seen the content of week 8, but professors are explaining us about BJT and analyze about its behavior, not MOS.
So one idea I can give is that you can also see, I think the previous year's videos are also available, right, in the YouTube channel that you have. This by BS
Yes, ma'am.
Electronics. You can
Yes,
go
yes,
there.
ma'am. But
You can go there. In case it is the MOSFET videos are not being released, because I don't know what is happening in the theoretical part. Like what videos has been shared to you, but you can always refer to the previous year's videos for the MOS, so you'll get an idea of it, and it is not very difficult actually. So and some other YouTube videos are also there, analog electronics and everything, some YouTube videos channels are there. You can, with that knowledge also, you can apply.
yes,
Okay.
ma'am, I can actually study from those, but actually the constraint is the time. Actually, we have exams coming, and till now we have to be prepared for till week 7. And so will it be intense? That does it differ? Most characteristic differ significantly from
No, no,
BJT,
no,
or
no, no,
it's
no. It is the same working. Okay. It is just some threshold value will change, and it is current dependent. BJT is current dependent. MOS is voltage dependent. That is the only thing. Okay. Just read some basics. Okay. It will not take
yes,
more
ma'am,
than
it will
two
be
to
tension.
3 hours of study, and you will get an idea of what of. And there are some books also you can refer. Refer some this analog electronics, read some books on the preliminary work, so it will not differ that much. That's why it is given for the experiment. So only the parameters will change. Let's say here you will plot IC versus VC. Now here you will plot drain versus IV versus VDS, that is drain source voltage. Okay, so those things will only change. Okay, don't worry. You can
Okay, ma'am.
you
And
won't need very much in-depth knowledge to do this experiment.
yes, ma'am, then it will be fine actually. And I was actually, since the previous student asked some doubt about the experimentation and how to show the data. Actually, previously in the recent analog week, I think it was week 4, I actually showed how I have connected the circuit and everything. Also showed the real measurement of the resistances connected, but I didn't show everything that I'm taking the I'm inputting this value, and I'm getting this output for half of the time where it was not necessary. I just showed the graph, plotted the graph. So is it an
Okay.
issue? Because
No, as long as see these all
ma'am, it's
things are
clear actually,
clear,
but
yeah, then it's fine. As long as the video is clear and it is not apparent that you have not copied from somewhere else, because
yeah.
maximum people does that. That is why we want the real time like
I
data.
don't think it will match with anything.
Huh.
Every measurement is different.
So
Okay.
that is the main idea. So then I have seen some
So you
people.
want to be sure that
Yeah,
the
that is the
content is
idea.
unique and we are performing its own. Okay.
That is the only idea. Okay. So maybe
Yes.
from now from this experiment you can just show some, if you think that you have not done certain things in the previous videos, you can incorporate it from this video onwards. Okay.
Okay, ma'am. Thank you.
Any more doubt?
I'm actually referring from like previous year videos that students uploaded in YouTube channels. They just measure the current in a wrong way. It is something which is misleading. And is it okay? Like previous in previous theory, like experiment, I just measured the current by measuring the voltage across the resistor. Yeah, but many people were measuring the current like across the resistor, which will not be.
Yes, correct. It
Yeah,
will not be so. What you have previously said, that you have to always measure the voltage, and voltage divided by the RC value will give you the exact
yeah. So
current.
is it measuring the current through this way is better way?
Yes.
Yeah. Because I also know that the multimeter will have some shunt resistance, and there will be
Yes.
some effect of the current while measuring it.
Yes. So
Yeah.
that is not that's why we are saying like you should this is the correct way.
Okay. Yeah. Just need to go with the theoretical velocity current by measuring the voltage. Sure. Okay, ma'am. Thank you.
Anyone, any more? Any more doubts?
What step voltage should we take? Like, how much step voltage that is not mentioned?
So I have already told, no, this you will get it from the data sheet. Okay, gate voltage and also the
No, I'm not saying gate voltage. I mean step voltage.
what?
Vary step voltage. Vary
Oh,
zero.
step voltage. Yeah, that you will 0 to 5 is there. No, you can take in maybe 0.5 or 0.2 like that. Better 0.2 you can take, so you get a more idea of how this current is behaving, transistor is behaving. Huh? So if you take 0.2 is it will give 1 in 1 volt, 0 to 1 volt, it will get 5 readings, to total 50 readings will get. No, 5, yeah, 25. So I think 0.2 also it's fine. Anyone has any doubts?
Ma'am, I was thinking that we are performing these experiments, but at the end of the deadline, when we have submitted it, we will get the scores depending on our performance. But how will we improve if we have make any mistakes? I mean, there is no any feedback from the
There
other
will
side.
so there will be feedback. So we'll check, and there will be some feedback given that these all things are not incorporated in your video. So we'll get the feedback once you will receive the marks. Accordingly, you'll get feedbacks as well, I think. If it is, if all the requirements are been completed, then we'll not give any feedback like, okay, very good, fine. But if you have not completed certain parts of the experiment, we'll specify that this is the part you have not completed. That's why some marks has been deducted. So that will be specified.
Ma'am, for the part for like for that LDR and LED part, is it okay to have a without a potentiometer? Can we have a like constant like resistor, like 200 ohm resistor?
Yeah.
Yeah.
So just make sure that the values, the fixed resistance value is enough that the circuit works. Okay.
Sure, ma'am. So it is no problem to have a fixed resistance.
No, there is no problem to have a fixed resistance because we are not varying it actually.
Yeah. Okay. Sure.
During the course of what our aim is to check that how the dependency of light on the LDR will change the light intensity of LED. Okay, that is our aim.
Sure, ma'am.
Anyone has any doubt?
And also when we are using DC voltage from the ADALM kit, many of the channel, and
your voice is not audible.
Hello.
Yeah.
When we are giving a constant voltage from the ADALM channel A or B, and measuring the voltage on a resistance with a multimeter, the voltage fluctuates.
I think that is in the previous experiment also I said some repeated sweep thing is there.
No, I'm saying that when I'm measuring the voltage with a multimeter.
You are giving DC voltage and you are in the ADLM kit. I think you have to remove some in the settings some repeated sweep so that
No, you are not getting what I'm saying. I am giving input from the ADLM kit. Giving input DC voltage.
DC.
Not any sinusoidal. It's a DC voltage.
Yeah.
And if I measure that voltage on a multimeter, the voltage fluctuates in the multimeter.
Okay.
I'm not talking about the
What have you,
pixel bulb.
what have you, during the other experiments, have you came across this problem?
No,
Actually,
because
yeah.
for the other experiment, I gave the input from the ADLM and also measured with the ADLM kit only.
Okay.
Actually, excuse me, ma'am.
Huh,
Actually, having the constant DC voltage will also have the glitch with having the repeated sweep enabling it.
I
So
think
maybe
so.
we could also try with like 10 seconds of repeated sweep. It will be fine for that. Because the glitches will be there for even the constant voltages also. I have measured it using the oscilloscope which is available in my college.
So you have to
Actually,
enable
ma'am,
that.
we have faced such issues actually when we measure input from the DLM channel A or B, suppose 4 or 5 volts constant DC voltage, and measure it only through a DLM other probe, then it's fine. But yeah, measuring through the multimeter, it fluctuates, and when we
Fluctuates
term
in
out
no, fluctuates in which domain? Like in the
In the
like
multimeter.
fluctuates
no.
like in the
Let's say I'm saying that the voltage should come 0.2. Okay, is it 0.25
if
like in the
uh,
which decimal?
No,
Because
it fluctuates with time, like
no,
there was some noise.
it fluctuates almost like a 1 volt up and down.
yeah, that is what I wanted to know. That it fluctuation is
Yes.
high or it is 0.2
No, it's
25666 like and then it becomes 0.257 like that.
no, it fluctuates very much, like 1 volt.
Sometimes it
fluctuation.
becomes zero even, even in negative. Then it goes all the way to 4, 5. I mean, it just swings rapidly. But
Have
actually,
you
when we
enabled
turn,
this? Have you enabled this repeated sweep and enable the disable? Try that.
But
yeah,
I
ma'am,
think the sweep
enabling it
setting,
goes.
I think the sweep setting is for any varying signal. But here we are not giving any varying signal. Huh? We are
But
giving only
I don't see. Just check with that also maybe because there are some glitches with the ADLM kit as well. So just confirm. I'll also confirm with that. Okay, I'll check this point. Okay, but you also confirm that whether enabling or disabling this repeated sweep option will remove that or not. Okay.
It
You are
solves,
saying,
ma'am. Actually, disabling the repeated sweep,
Huh.
it holds up at constant voltage.
I think so. Yeah. If you disable the repeated sweep, then it will show the same voltage, correct voltage in the multimeter.
Yes, ma'am, it works.
Then it's fine. Then do that. I think that is a problem because I think during the first set of students we had they also asked about that and some this repeated so you have to disable I think no.
Yes, ma'am.
Uh-huh.
Actually, it turns out to be.
You have to disable the repeated sweep and then the same multimeter voltage becomes constant. Have you
Ma'am,
checked?
can I ask one thing?
Yeah.
Are you aware that when we generate a square wave using the ADLM, suppose 1 hertz or 50 hertz or 100 hertz, so there is some ambiguity in the signal.
Okay, you are getting some problem in the signal from
Yeah,
the ADLM.
actually, I was getting problem in the digital week, but since I think if you are aware of the problem, then you can share with us.
Sure, I will go through that then. Okay, once this
Okay.
week I'll go through and then I will confirm what is the problem with this. The square wave and constant. Oh, means all the things. This kind of same code whether I'm getting the correct voltage or not in the multimeter. I'll confirm this. Okay.
Yes, ma'am. Okay.
So just disable
hello?
that. Yeah. So.
You are right. I did it right now. Disabling the repeated sweep makes it constant. Thank you.
Makes it constant, no?
Yeah. Thank
Because
you.
as long as I remember, Bobby sir, Professor Bobby has also specified that to the students at that time. That was a problem with the ADLM kit. Okay.
Okay.
So you have to disable that.
Actually, ma'am, the response time of a multimeter is very slow. It is about 100 milliseconds. And having it in like 100 milliseconds or 10 milliseconds would will have a fluctuation with the reading over the multimeter. And even if we have like a 1 second sweep, there will be a fluctuation for every 1 second, and it is due to the glitch with the ADLM kit.
LELM kit, correct,
Yeah,
correct.
having it in 10 seconds will be better to take the readings from the multimeter and also the ADLM kit also.
Better you disable that, okay? Disable
Yeah, it is.
the repeated sweep, no? So that already will solve this issue.
Yeah, but there is another one issue that if we remove the repeated sweep, we cannot measure the average voltage using the another channel available in ADLM kit.
Oh, okay, that is an issue now.
That is also there's an issue with that.
That is a glitch from this. That is a problem with this kit. Okay.
Yeah, that is a problem with this kit. Yeah.
So better when you in this experiment you are using DC voltage, right? All through, right?
Yeah. Yes, ma'am.
So you can do disable this thing. Okay.
Yeah.
I think this problem is solved, but I'll also once confirm. Better. I think I did this. Removed this disabled this thing. Repeated sweep, and this then I got constant voltage at that once I did that part. Okay, so I think everybody has also confirmed that this thing disabling the repeated sweep will give you a constant voltage in the multimeter. So, about the square wave thing, I'll just see.
Yes, ma'am. It will be.
So you are saying that in the when you are giving the square wave, what is the problem it is coming?
Actually, I was doing some experiment that, like the counting. I was building counting circuit, and I checked for almost 15 hours or 10 hours that is there any issue with my connections. Everything was fine. Once in 10 or 20 trial, it just works fine. It just counts normally. If there was some glitch in the circuit, it should not count that way. Even in the down counting, it was performing that way. So I suspect even students were telling that there is some issue in the signal generation from the ADLM kit. So
Yeah.
some students knew that they were using Python libraries to provide the clock signal, a square wave generation from the digital pins. But
Okay.
every student don't know yet the Python
Better you
programming.
can better you can ask your batchmates, okay, that because I don't know about the digital part and what all problem. I have not seeing the digital part of the experiment, so you can once you during your doubt clearing session in the digital part, you can ask this problem to them. Okay.
Ma'am, will professors be interacting with us in this course as they did with the previous term students?
In the digital part also, one
No,
TA is,
in this analog part.
this analog part actually I only take care of, but if you want to discuss with professor about any doubt, so you can just mail him or ask through Victoria. Okay.
Okay.
Any more doubt? If nobody has any doubt, you can leave the meeting. It's already 5. So,
Excuse me, are you available in Discord? Like, are you available in Discord? Can we tag you in Discord for queries?
I did not get you.
Are you available in Discord, like the chat forum
No. Sorry.
of the course?
I'm not available in whatever some chat forum you're saying. I'm not available in that.
Ma'am, I wanted to share something on the course. Actually, like if I take example from the other course, Linux cells, when we were doing labs there, so what we are supposed to do, actually we have to prepare the submissions and submit it, but instructors were or TAs were available with us all the time. Whenever we were in need or we need to ask anything for an issue, we just messaged them in the Google space or any separate platform provided for us. So, ma'am,
What I was telling.
yes, but since even the electronics lab is much intense from that, and if we get stuck into any issue, then actually it is very frustrating to sort out at that time. As you know that also for any specific week, you only interact. You are given to. We are given only one interaction with us, so we can ask any doubt. But it is not, we don't think that it is sufficient, ma'am. If we need anything, we are, it's very complicated process that we mail to Victoria ma'am or anything, then I mean we will not get response in before the deadline. So ma'am, can we do anything on the
Okay. So maybe I'll talk to Victoria about it, because previously whatever the students had, if they have any doubt or if they have, so they used to convey that to Victoria, and Victoria has to ask me. But I
but
will,
ma'am, it's a very round process.
yeah, maybe.
Like also previously we were in just direct contact with the TAs and the instructors in the Linux cell course. Can't we get that I mean like that?
I can just share your view with Victoria, and then we can see what can be done. Okay.
Okay, ma'am, please. It will be great if we.
Sure. But if at all, if you have any problem, like altogether many people are having facing some issues, you should always notify Victoria that we're facing some issue, so we can have a small TA session again sometime, except the weekends. Okay. We can have some small GMeet, like a meeting of maybe 30 minutes again for a discussion that we can do. And then the deadlines can be extended for some 2-3 days, and then we can just see what problems you're facing, and then we can do it. Okay. I'll convey your messages to Victoria.
Okay, ma'am.
If you don't have any more doubts, you can leave the meeting.